Okay, so next up we have arrays ADT, in which we have to create an array and perform actions on it. So first, to everyone knows, struct array, pointer to the array, current size and total length it can store. Main function, declared a list A of data type struct array, same, get the total size, total length, and provided that amount of space, then how many elements you want to store. It's like the current size. Okay, so next I'm creating an array and storing in the ARR this pointer. This pointer will have access to all the elements. In C choice, do while loop, this is the whole loop. 1 2 3 4 operations, insertion, deletion, linear search, and display is not an operation, just to display the array. Took the choice if C is equals to 1. For insertion we require two things, index and element. At what index you want to like insert, and element, what element you want to insert. Just took this, then call the insertion function, pass it by reference because we want to make changes in the original list A, not to make a copy. So I just passed index and element. So this is the insertion function, int I. So I have checked for the enough space, if there's enough space. For example, we have a total length of 5, and if size is 5, then we can't like store more much. So I have just checked this, first check this, then I've used a for loop for wait a sec, I need to explain this. Okay, so for instance, this is an array. 1 2 3 4 5. Okay, so these are the index. Okay, so if I want to insert, first of all I have to make a space. We can't insert like here, like go there and insert, because 3 will be lost. So for that we have to make space. How do we make space? I will take a pointer I, which will point to like this index, the last element of index. So I will run a for loop which will be like ARR of I plus 1 will be equal to ARR of I. So what it does, it like copies to here. So I'll show you what it looks like. Okay, 1 2 3 4 5 and 5. So you can see 1 2 3 4 5 elements. Now there are 6. So wait a sec. So now currently I is pointing to this, as we know from here. We saw I is pointing to this. Now we will decrement I by 1, minus minus, same. Okay, so I will point to here. Now we will do the same thing, this same whole thing. It will copy here. It will look like 1 2 3 4 4 5. So it will go here. Now I decrement, so it will go here. So for instance, we want to insert at this position. We will again copy. It will look like 1 2 3 3 4 5. So I will be again decrement. So I will be at this position like 2. Now we don't want to insert at 2. We want to insert at this. So ARR of I first of all, after running all this, also the loop, now we will do ARR I plus 1 is equals to element, whatever the element you want to like store. This is the I where is it's pointing. So now here we will put the element whatever we want. So yeah, same. First I will be like pointing to the last element index, and I is greater than equal to same stuff I just do. And one more thing, we have to increase the size by 1, of course. Done. Okay, so yeah, so this will do this same. For deletion we just need an index. So where's delete? This is so for delete, wait, I won't take much space. For deleting 2 3 4 5, like for instance there's one more space and this is the area. So if I want to delete 2, I will point here, not me, I will point here. So I will copy this here, like 1 3 3 4 5, then I plus plus. Now I will point here, same copy and at last decrease the size by 1. Yeah, same, you are just copying starting from index, yeah, same, and decrease the size by 1. So search, not gonna explain, same, easy. Display, same, easy. Now wait, this is not display, this same, like nothing new, and it will print the current size. So this is the same thing. Insertion, deletion done, linear search done. Wait, let me show you again. Same, if like we found the key and return the index of the element that we found. So this is what element you want to search. In key, takes the input, does same thing. In C for is equals to 4, it will display, and at last we just free the memory. That's our job. Like if we just take the memory from the heap, that is allocate the memory by mlog or clog, so we have to free it. That's our job. So that's it. Thank you.